right, I wanted to do an example of a second order differential equation that we approximate using series. So we're going to try to solve this initial value problem by guessing the Maclaurin series for a solution. And once again, we're going to find just the fourth Maclaurin polynomial. So we're basically going to find the series up to and including the t to the fourth term. Okay. Very important to remember, we are not claiming that P4 is a solution, so we're not plugging in the derivative of P4 into y prime, because the derivative of P4 wouldn't include any terms that came from the higher order terms. What we're plugging in for y prime is the derivative of the entire series. And what we're plugging in for y double prime is the second derivative of the entire series. So while the term of degree 5 will not occur in P4 of t, the term of degree 5 will affect the first derivative and will definitely affect the second derivative as well. Okay. All right, so let's see. We're basically guessing that y of t is the sum as n goes from 0 to infinity of a sub n t to the n, which would make it a naught plus a1t plus a2t squared plus a3t cubed plus a4t to the fourth plus dot, 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 dot. Okay. That would make y prime equal to this just goes to 0, so I get a1 plus 2a2t plus 3a3t squared plus 4a4t cubed. So notice, as I'm writing things, I'm lining up the terms with the terms from y that had the same degree. To keep track of where I am, I'm keeping my right hand pointing at the term whose derivative I'm taking, which I'm then writing right here. Okay. And of course the pattern will continue, so I'll get plus 5a5t to the fourth plus dot, dot, dot. Y double prime then is going to be, well, when I take the derivative of a constant, that drops out. When I take the derivative of 2a2t, I'm going to get 2a2 plus, now here I'm going to get 6a3t. Here I'll get 12a4t squared plus 20a5t cubed plus dot, dot, dot. Okay, so that's what we're getting for our y prime, and our y double prime. Of course, I'm going to have to take into account that I've got 2 y primes and 3 y's in this differential equation. Let's actually go ahead, though, and calculate the series for cosine of 2. You know what? Actually, I'm going to change my mind just because of the limited board space I have. What I'm going to do is down here, I've got just enough room to write what I'm going to have on the left-hand side of my differential equation. Then I can erase this and work with the cosines on the right-hand side. So what I have is y double prime. Oh, and actually, I've got just one copy of that, so I can take advantage of the fact that I've already written that. Okay. But I'm going to have 2 copies of y prime and 3 copies of y. So 2 copies of y prime just basically means I'm going to come across here and I'm going to double all of these terms. So I'm going to have 2a1 plus 4a2t plus 6a3t squared plus 8a4t cubed plus, 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 plus. Okay. 3 copies of y means I'm going to come to y and I'm going to triple each of these terms. So I'm getting 3a naught plus 3a1t plus 3a2t squared plus 3a3t cubed plus dot, 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 dot. Now you'll notice I didn't actually carry this line out until degree 4. That's because all I need is enough information to solve for my coefficients up to and including a4. I think I'm actually only going to need to go to the degree 2 terms because that's the first place that a4 shows up. Okay, so even if I'm looking for the 4th degree polynomial, sometimes I can figure out what that is just writing out the first few terms of y prime and y double prime might not necessarily have to go to the degree 4 term for everything. Okay, excellent. So that's what I have on my left-hand side. Now the right-hand side, we're going to have cosine of 2t. So let's just remember, cosine of t is the sum as n goes from 0 to infinity. Signs are going to alternate, so it's negative 1 to the n. That's true for both sine and cosine. But then cosine is my even function. So it's even powers, so t to the 2n, over even factorials, so over 2n factorial. Okay. Now, that means that cosine of 2t is what I get if I just replace the t with 2t. So this is going to be the sum as n goes from 0 to infinity, negative 1 to the n, 2t to the 2n, oops, two t to the 2n over 2n factorial. And I can simplify that a bit. That's the sum as n goes from 0 to infinity, negative 1 to the n, 2 to the 2n, which is actually just going to be 4 to the n, times t to the 2n, all over 2n factorial. Factorials do not distribute over that multiplication. I'm taking factorials of even numbers there. Okay. All right, so let's just write out what we have then on the on the right-hand side. Okay. So when n is 0, I'm getting negative 1 to the 0 is just positive. 4 to the 0 is 1. T to the 2 times 0, that's still 0, that's just 1. 2 times 0 is 0, factorial is 1. So I'm just getting 1. That's a constant term. Okay. Now, I'm not going to get any t's because I'm only getting even powers. So when my index is 1, the power of t that I'm getting is t squared. So I'm going to jump to this column. I don't have anything in the t column. Okay. So what I'm getting then is negative 1 to the first power, so that's going to be a negative. 4 to the first is 4t squared over 2 times 1, because remember my index here is 1. 2 times 1 is 2 factorial, that's 2 times 1. So this is 4t squared over 2. And I'm going to go ahead and just simplify that to minus 2t squared. Okay, I think that's all I'm going to need. Because if n is 2, I'd be talking about t to the fourths. Doesn't look like I'm going to need to go all the way out to t to the fourths. I will make it, I don't think I'm going to need it, but I have 0 copies of t and 0 copies of t cubed. Okay. All right, excellent. So now I want to try to start finding what my coefficients are. Now, the initial values that I was given get me started. A sub 0 is 1. A sub 1 is 2. Remember, the formula for the coefficients in a Maclaurin series are just the nth derivative at 0 divided by n factorial. So when n is 0, the 0th derivative is just the function, so we get the function at 0, divided by 0 factorial, which is 1. Okay. When n is 1, we get the first derivative at 0, we were told that was 2, divided by 1 factorial, which is 1. Okay, so I've got my first two constants, and now I'm just going to start looking at what I have. If I look at the constant terms here, 1 is the constant term on the right-hand side. That's got to equal 2a2 plus 2a1 plus 3a0. That's the sum of the constant terms from the 3 terms that I have on the left-hand side. Now I can plug in for some of these. So I'm going to be solving for a2, but I know that a1 was 2, so this is plus 4. A naught was 1, so this is plus 3. So let's see, that's a 7, subtract that over, negative 6 equals 2a2. a2 is negative 3. All right, so I want to keep going. I want to try to find a3. Now, I am not going to skip to the t squareds. I'm going to look at the t's. I'm going to use the fact that I don't have any of them. So that means the number of t's that I have on the right-hand side is 0. And that has to match the number of t's that I have here on the left-hand side, which is 6 copies of a3 plus 4 copies of a2 plus 3 copies of a1. I know all of these except a3, so I simply plug in for the 2 that I know. So that's 6a3. a2 we said was negative 3, so that's going to be minus 12 plus 3. So that's a minus 9. So 9 is equal to 6a3. a3 is going to be 9/6 or 3/2. Excellent. So, got one more to do. I just need to know a4 because we were just going for the fourth Maclaurin polynomial. So let's see, we just used the t's. Let's jump to the t squareds. So for the t squareds, the number that I have on the right-hand side of my equation is negative 2. The number that I have on the left-hand side is the sum of these coefficients. So that's 12 copies of a4 plus 6 copies of a3 plus 3 copies of a2. Once again, I know 2 out of the 3, so I'll just plug in for those. So negative 2 is 12a4 plus 6 copies of 3/2, that's going to be plus 9, plus 3 copies of a2, oh that's nice, that's going to be just minus 9. So we've got negative 2 is equal to 12a4. a4 is negative 2/12, which reduces to negative 1/6. Fabulous. So we've got our coefficients. Let's not forget to actually state the answer, though. So P4 of t, the fourth Maclaurin polynomial, which again is just a partial sum of the series, which is what we're claiming is the solution, is going to be 1 plus 2t minus 3t squared plus 3/2 t cubed minus 1/4 t to the 4th. Does end up being a 4th degree polynomial. Most of the time, the fourth Maclaurin polynomial will be degree 4. I will just point out it is possible that you could solve for this coefficient and it could be 0. If this coefficient were 0, this would be a 3rd degree polynomial. We would actually get the same formula then for the 3rd Maclaurin polynomial and for the 4th Maclaurin polynomial. So when I say it's the 4th, it's up to and including the t to the 4th term. If that is non-zero, it will be a 4th degree polynomial. All right, so this is kind of a nice section to end on, I think, because I mean, it's maybe a little bit tedious, but it's not particularly complicated. So just a lot of simple calculations, then we've got it.